Welcome everybody to the New York Federation of Solid Waste and Recycling, our first ever virtual session, virtual conference. My name is Kelly Timbrook. I am the project manager at Casullo Resource Solutions, as well as the president from NYSAR 3. If you were on the first session this morning, you heard my whole spiel about NYSAR, as well as from the other two organizations that make up the Federation. If you'd like more information about those, feel free to go onto the Federation website, and there's links from there. So due to the pandemic, the normal conference that takes place in Bolton Landing was switched to a virtual conference where we all are right now. So over 3 weeks, we had 6 topics, and we are now on our third one, our second week. So we have 1 more week and 2 more topics next Thursday. When you register, you are welcome to attend one or all, whatever you find the most applicable. And all of the sessions will be recorded, so you can always go back to them later as well. So I'd like to thank Barton and LaJudas for the Zoom platform, as well as for Luann Meyer's time for getting all of this set up and allowing us to use their Zoom, as well as NYSASWAM, who is allowing us the opportunity to issue the PDHs. So for the PDHs, if you're interested in them, you do need to be registered on your own name. You can't be 2 people on 1 account. And then once the presentations are over and you have stayed for the full time, you'll get an email with the form. So you fill out the form and send it back, and the credits will, you'll be able to receive your credits that way. So a few other housekeeping items. As I mentioned, we are on the Zoom webinar platform. All attendees are in listen-only mode, so you're muted. To submit a question, please use the Q&A box at the bottom of your screen, and the chat box has been disabled, so you will not be able to use that. But you are welcome to enter your question at any time during the presentation, and the monitor will hold them and collect them until the end of each speaker, and then at the end of the presentation. So with that, I am going to hand it over to Bill Rabbia, who is our moderator for today. So Bill, if you'd like to take it away.
Thank you, Kelly. I will be your moderator today, and just to add to Kelly's statements, please submit your questions as our presenters are underway. As you have questions, I plan to have presenters answer questions after each presentation. So we have 3 very good presentations today, and each is allotted a half-an-hour time frame that includes time for Q&A. So submit your questions and we'll address them as time allows at the end of the presentation. So our first presentation is Posi-Shell, multiple BMPs with 1 system. We have 2 presenters, Mr. Joel Lanz. Mr. Lanz is the president of LSC Environmental Products and has over 30 years with LSC. Joel is a MOLO certified and was recently awarded the 2020 MSW Management Legacy Award, honoring 30 professionals impacting the waste industry for the past 30 years. Mr. Ventimiglia is the Northeast Regional Manager for LSC Environmental Products, and Ben maintains the New York State Landfill Operator Certification, General Mineral Miner Certification, and he is also MOLO certified. So with that, I'm going to hand it over to Joel and Ben. And again, please submit your questions. We'll address them at the end of the presentation. Take it away, Joel and Ben.
All right. Well, thank you very much. I'm Joel Lanz. I'm going to start out today, and then I'm the president of LSC. Then I'm going to hand it over to Ben Ventimiglia. He's our Northeast Regional Sales Manager. As you all know, today we're going to be talking about controlling odors in a landfill. LSC's been involved in this type of work for quite a long time, about 30 years now. And we started here in upstate New York, and we've now expanded to almost every state in the U.S. with our products and in numerous countries around the world. Domestically here, we have a team of sales engineers and salespeople that handle our business in the U.S. and with also a distribution network in the U.S. And then domestically, for the most part, we work through various partners and distributors. Over the years, from the beginning, Posi-Shell was our very first product that we developed in Albany, New York. And since that time, we've actually have a full line of products, including dust control, vegetative products, hydroseeding products. We build our own equipment. But today, for this presentation, we want to focus on our odor control products. So we're going to be talking about our Posi-Shell environmental coatings, our solar spark vent flares, and another product we have called Odor Shell Complaint Eliminator. So to jump right into this, I'm just going to give a little background about our Posi-Shell product. Then I'm going to hand it over to Ben and let him talk about some case studies and some more details. So Posi-Shell is it's a spray applied mineral mortar product, and it's used as a daily cover. And of course, any product that's going to be used as an alternate daily cover needs to meet all the RECRO requirements. Posi-Shell meets and exceeds all of these requirements. It's reliable, it's cost efficient. Again, we do this in hundreds of landfills every night throughout the country. There's, of course, any situation, most people are going to want to figure out how to save money. So we see a pretty significant cost savings in operating cost of running soil moving equipment. And then, of course, there's the valuable thing about airspace. And our experience over the long tenure of time here has been that we save sites approximately 20% airspace, meaning their landfill cells will last longer. It also has a lot of interesting benefits. We're creating a slurry on site, and many sites actually that collect waste latex paint will use that product in the Posi-Shell mixture as a way of recycling waste latex. So that's typically the Posi-Shell for alternate daily cover is it's just going to be a product that comes in a bag. There's a piece of equipment on site. We mix this with water. It creates a very dense slurry that seals odors and also has a bit of odor filtration of odors. The base chemistry or the base materials we use are very similar to materials used in kitty litter. So from a technology standpoint, that's what's happening with our daily cover. And our daily cover products, we call them daily cover, but they could be out for longer than daily if required. However, we also, as you know, get into a lot of situations on a landfill, whether it's trash or soils that are very permeable, where odors are escaping in other situations. So it's very simple with the Posi-Shell to alter the formulation to become much more durable than daily. So we typically do this with some form of something that's going to help harden the material. Most of the time, it's going to be a cement product. So when we take Posi-Shell and add a durability enhancer, now we can make a coating that's going to last for beyond a year with very minimal upkeep, very minimal maintenance. The beautiful thing about it, and we'll show you some slides here soon, is it can be applied virtually anywhere. We make equipment that is designed to be in landfills, that's towed behind bulldozers. So our motto is wherever your bulldozer can go, our equipment can go. And then if there's places the bulldozer or the equipment can't go, and we've applied this through hundreds and hundreds of feet of extension hose if required. The product improves runoff. We put a very thin coating of the material on various surfaces on a landfill, and in some cases we can now see rainwater come off at 95%. Water typically going into the landfill can be reduced dramatically. It's going to improve gas collection in situations where it allows you to suck on the gas system harder. Of course, it's going to reduce odors, and then it also is going to reduce erosion and sedimentation, keep the soils where they belong. So again, we have this daily cover version that every night, instead of using a 6-inch layer of soil, you can put Posi-Shell down. Then there's an intermediate version where, depending on the state, the requirements, we see intermediate cover ranging from 12 inches to 18 inches in some cases. And we have approvals in a number of states to replace some or all of those types of covers. So again, we've been doing this for many years. And again, on the intermediate cover, very similar, we can create a very durable product that can be out for a long time. There's airspace savings in intermediate cover as well. There's going to be all kind of improvement with the gas and erosion and sedimentation in very dry climates, not so much maybe in New York State most of the time, but also windblown dust gets reduced dramatically. And we've already talked about the costs. And one of the other really important things about the Posi-Shell is when you need to move on to the next phase, whether the next phase is hydroseeding or closure, the Posi-Shell doesn't have to be removed. It can simply be tracked in with a dozer. So if hydroseeding needs to occur on the slope that's being covered, come in the following year and simply track over it. It's a mineral-based product that kind of just joins into the structure of the soil, and we have no issues whatsoever with vegetation growing with it. So again, there's two types of intermediate cover in our opinion. What we've dubbed alternate intermediate cover and enhanced intermediate cover. So what that means is alternate intermediate cover, as similar to alternate daily cover. These are situations where the product can be used completely in place of intermediate cover soils. And we have approvals for this. This picture here is taken in Florida. We have approvals for this in South Carolina, where the product can be left out for much longer than overnight. It varies from state to state. Some cases it's 30 days, some cases it's 180 days. And we've had these things tested by third-party firms. And again, what they're checking for would be what we're always looking for, which is odors, blowing litter. In the cases of this one in Florida, there was a lot of work done about the water, the groundwater monitoring. We pass all these different tests. So that's alternate intermediate cover. The other version is enhanced intermediate cover. So this one is where we're leaving the statutory intermediate cover in place, whether that's 12 inches, whether that's 18 inches. Again, that varies. The reasons we're doing this is we find throughout the country is the different types of soil structures. There's poor soils in many places are very erodible from rainwater. And then the other one is that soils are very permeable to gases escaping. So again, Posi-Shell is used regularly and has been tested many different sites, hundreds and hundreds of acres applied in this manner to help improve the odor emissions at a landfill. So this slide here is this. We take odor control very seriously because, in our opinion, it is obviously a landfill manager has so many things they have to worry about every day. Yeah. But to us, odors seems to be the top of the top of that mountain. Where if odors cannot be controlled, these are the things that we've seen shut landfills down, and none of us want that to happen. And we put this slide in here because we take this thing very seriously, and the Posi-Shell, LSC, our logo actually stands for Landfill Service Corporation. We do things beyond landfills today that we didn't used to 30 years ago, but the company was started and founded around doing landfill covers, but the reputation of the company has allowed us to become involved with things such as the World Trade Center, when landfill landslides occur, and we all know of the ones that have occurred over the years. the Posi-Shell products used to control the odors there because it's very versatile. Landfill fires, actually wildfires out west. So we're happy that the integrity of the products actually have carried far beyond our very important landfill business to some of these worldwide events, if you will. And we're pleased that they're working well. So I'm gonna now hand this over to Ben. That was just an overview. Ben was gonna get into some more of the details of some of the situations we've worked on and some of the case studies.
Thank you, Joel. So what I'm going to do is kind of go over three little projects and case studies that we've done using Posi-Shell for an intermediate cover / odor control application. So like Joel mentioned earlier, in the state of Florida, we have preliminary approvals statewide. It's called an expeditious permit modification. We applied a little over 30, I believe almost 30 acres so far at Hernando County. So what they were able to do once they applied this over a very porous soil was extended the landfill life a little over 2 years, which was, obviously, replacing all that amount of soil with a very thin layer of Posi-Shell was very advantageous. Soil conservation, they were importing some soil tied together with the fact that they had equipment being used, fuel savings was a little over $400,000. Their operational savings a little over $75,000. Reduction in fuel maintenance. Some of the bigger things, in our opinion, was the reduced leachate generation, because you're actually shedding that environmental load off instead of permeating through and getting collected by your collection system. And then, as Joel mentioned earlier, the gas collection. It provides a much tighter seal and allows that landfill gas collection to draw a little more efficiently. So based on their third-party projections through their engineering firm, they were looking at a little over a $10 million savings over the project life. Also, another pretty large project that we worked at was a private facility in California, outside of Greater Los Angeles. They had some major issues with odor, and we're kind of looking for something to kind of seal things in and kind of stem that. Once again, very high permeability soil, and they were actually under a consent decree. So what we did is we've done a little over 37 acres at the time of the project since 2017, minimized airborne dust where it was applied, particularly on the slope areas. And once like I mentioned earlier, improved a barrier as far as ambient air being drawn in. The other thing that probably everybody kind of keeps in mind is that when you draw on that system a little harder and get that ambient oxygen, it could lead to some combustion issues. So that's another thing that we found over the years that is kind of another, what I call like an unintended benefit, is that you're allowed to draw a little more oomph on that system and not have to worry about a combustion issue. Like I said, provided an interim cover, very easily integrated into the vegetative cover when it needs to be removed, versus, the other side is to put a geotextile down and have to peel that back. Very labor intensive. One of the landfills that I actually personally had was a facility outside of Rustburg, Virginia, outside of Lynchburg. This was a facility that didn't have an active gas collection system at the time, and they were getting some odor issues. So what we did is we put a pretty robust formulation of Posi-Shell down, a little over 5 acres. And as we were putting this down, they actually installed 9 vertical wells and tied it together to a portable trailer-mounted gas collection system on a vacuum. And they actually had their engineering firm monitor this very closely. The surface methane concentrations were a little over a 20% reduction, and about a 44% reduction where the Posi-Shell was versus the control area that was not applied. The surface H2S concentrations was a little over 56%, with a median reduction of 50% over all of the 9 wells that they put in. And then, of course, they had qualitative data that supported the information that they had provided, and they've been very happy. Since then, they've actually upgraded their system and actually have a more of a live system that's been installed. So kind of the gist to this is, an improved gas extraction system, will dramatically reduce odors. So some other applications that we're able to do is kind of around wellheads. That's kind of something that is a path of least resistance for the gas. So, we do a great job, sealing everything in, but around the wellheads, that's usually an area where we're starting to see some hits. So a lot of our customers have kind of sprayed this around their wellheads to kind of seal things in. During some independent testing that we've been doing over the years, we see about a 93% reductions in VOCs in areas that have been applied with our product.
Hey, Ben.
Yes, sir.
Go back that one slide, just so the group, if you don't recognize that device, that's called a flux chamber. It's used for measuring odor emissions and VOC emissions out of a land anywhere, but this is a slope of a landfill. Actually, this is in Hong Kong, and what they'll do is they'll get a baseline reading on a slope that doesn't have the product on it, and then they put it on the slope that does. So this particular one is our Posi-Shell, and yeah, they see like a 93% difference about what's coming out of there. The brown there around it is just a wet Posi-Shell that's used to seal it off, so they make sure that the emissions are only coming from underneath that device.
Yep. So these are some pictures of that facility out in California with this actually applying. So you can see it's a pretty wide open, vast area that we applied the product to. One of the conclusions in that project in California is that, it provided an improved barrier to ambient air, allowing an increase in applied vacuum without increasing oxygen, thus increasing the vacuum for additional gas collection. The other thing I wanted to add, I should have mentioned earlier, as far as the other thing too, is that there's always a concern when you're drawing in more ambient oxygen, especially if you have a gas, or especially if your system is like a gas to energy plant. You need to kind of balance that oxygen, because you can actually have a time where when you draw a little harder, it kind of throws those numbers off a bit. And obviously there's a concern when they're at the actual plant, when they're getting too much oxygen versus what they normally get. So that's just another little thing I should have thrown in there. Some other pictures of some facilities that we've used where we sprayed around the wellheads. Some of the testing that we've experienced, obviously well 1 is applied with Posi-Shell, and well 2 in the red is bare soil. So you'll see over time that there's a pretty dramatic decrease in emissions where we apply the EC4 Posi-Shell around the wellheads versus the bare soil. So another thing I want to throw in there is we have another standalone product called Odor Shell. It's actually a variation of Posi-Shell with some very highly concentrated odor counteractants in it. We kind of leverage a 3-pronged approach of sealing, filter, and neutralizing odors on contact, mainly used on any kinds of piles of any kind of special waste, working face odors way above and beyond normal, what we would consider normal. Not necessarily great for slopes. That's more of our EC formulation, but just wanted to throw that out there as far as, for working face odors and special waste odors. Like I said, it's a variation of our Posi-Shell product infused with neutralizers. It adheres to any surface in wet or cured form. We can also mix a durability enhancer in this too to kind of extend that somewhat and give you up to a year performance with that. So this is a slide of some of the testing that we've done, like Joel mentioned earlier with our flux chamber testing. We usually see anywhere between 93 to 98% reduction in VOCs. So I'm going to turn this back over to Joel, kind of talk a little bit about our solar spark vent flares.
And how much time do we have left? And this is our last piece, but just give me an idea of
5 minutes.
Okay, so we'll just go through this rapidly. Talking about landfill odors, my long experience doing this is I've always told people if I can smell the landfill a mile away when I'm driving up to it, and we've all run into cases maybe like that, that's gas. Okay, so the odor is going to emit from a couple places: the working face and gas emitting that's not being collected or destroyed properly. And my experience is these gas odors are going to be the ones that travel much further. The working face odors, to me, don't travel that far. So you have a good source of covering the working face, you're going to take care of that. However, landfill gas is going to come out of the landfill somehow. And I get passionate about this because I don't care what you cover the landfill with, the gas is going to come out. So we developed many years ago a product that frankly we thought would eventually go away. So we have these solar spark vent flares. They're designed just to be placed on the vent. We'll show you some pictures a little bit later that they can actually be installed just about anywhere. In the face of active gas systems and waste to energy plants, which we think is a great thing, we thought these flares would saw their day 20 years ago and then they would go away. However, we still actually place a lot of these flares because what we've learned is gas in landfills can be very tricky. And frankly, it's as I mentioned, it's a massive odor source. And so where we find ourselves placing these flares is number one, in situations where gas collection is not economically feasible. Number two, where a gas collection system might not be completely connected. And number three, where a gas system might not be functioning properly. I made, these slides were made for a presentation we did in Asia. So the graphics here are kind of designed because I knew we were dealing with a bit of a language barrier. So the first situation here is solving the problem where you got ahead of me here, where a gas system might not be feasible. We have many customers that just place these solar spark vent flares on the wells that are in place. They can be installed in an hour. They're very economical, and they are rated to at 98% efficiency. And the design of the flare head that you saw earlier this product was developed at the City of Albany landfill many years ago. They function in wind. The sparking system, if it happens to go out, which happens very rarely, it's on a constant solar spark. So they're very reliable. There's thousands of these flares throughout the world. So we have the situation where an active gas system might not be feasible. Go ahead. Yeah, the smiley face was, that was for international. So in other situations where we have, there's possibly a system where there is an active gas system, waste to energy, but what we've run into many times is parts of the system aren't connected. So the picture you'll see here in a moment is a picture we have a large customer operated by Veolia in Hong Kong. They have active gas collection, but they don't drill the vertical wells until in the new cell until the cell is completed. So what they've done is placed our flares on the wells. They have flares they can move around in the current cell until it's connected. So again, they're able to destroy the gas and destroy the odors. This is a picture at a very large facility in Hong Kong. With, as you can see in the background, we took this at night intentionally. There's 100,000 people in those apartment buildings looking at 54-story apartment buildings looking down on this landfill. So they're very serious about odor control there, and they utilize these flares regularly. And then the last scenario is where this happens fairly regularly, actually, in Asia, where the monsoon rains and things come, and people have a gas system in place. However, the landfill gets too much water in it, and the wells don't work properly because they are blocked and they get watered out. So what happens in cases like this is, again, we've been able to help people install these flares. Go ahead, Ben, find the picture. Go to the next slide. Yeah. So this is a site outside of Ho Chi Minh City in Vietnam, and they have, I believe, 40 to 60 of our flares. They actually have an active gas system, but it's not working properly. So they use a membrane in this particular case to trap the gas, and then they just basically set our flares and put a hose underneath the liner, if you will, and they collect and burn all this gas. And that, I believe, is the last slide, Ben. Yeah. Okay. Now these are some pictures from many years ago, to show the flares in various different places they can be installed on a landfill. Anywhere there's gas hanging around in a landfill, these flares can be installed. We actually build a solar powered vacuum that can draw gas to the flares as well. And that concludes our presentation. Again, that's a pretty quick, pretty high overview of some of the things we've been a part of in trying to help landfills control odor.
Well, thank you, Ben and Joel. Obviously, you guys have a lot of multiple products, multiple formulations. I guess I have one quick question related to your products for just daily cover, alternative daily cover. Do you have a general rule of thumb from a cost standpoint that a landfill operator could use to kind of, before contacting you, come up with a, preliminary budget?
Sure. We run with, I would say 2 to 4 cents per square foot. And the reason there's a range there is regulations, I guess. I don't know how better to put it than that. Many of the customers will use our base mix that we first started talking about, and they may put it down thinner than we even recommend. Other places where the regulations are extremely high and very stringent, then they'll put it thicker. And in some cases may add the durability enhancer to it to create a denser, better cover. But I think it's fair to say between 2 to 4 cents is about what we average. And the product can be, it actually can be applied through standard hydroseeding equipment. So if somebody already owns a piece of equipment, they'll be able to use the product. If they don't, we have a full line ranging from very small. Well, we go from a 300-gallon unit to a 3,000-gallon unit. So that the equipment is a one-time purchase. That stuff is extremely durable. So it's going to be at a site easily 7 to 10 years, if not longer, before they have to think about replacing it.
Well, very good. Thank you. That's very helpful information. And we, as all the attendees know, we're going to be providing these presentations on the Federation website. It obviously will have all the contact information for all of our presenters. So again, I'd like to thank Ben and Joel for your presentation. Our next our next presentation is a case study of how alternative covers can help solve operational issues. And our presenters are Michael Casullo with GHD in Niagara Falls and JD Mohr of EPI Environmental Products. Mr. Casullo is a civil engineer. He graduated from SUNY New York, Buffalo. He joined GHD in 2011. He works out of the Niagara Falls office. His professional experience is centered on the solid waste industry, having spent considerable time assisting landfill clients with air monitoring and reporting, troubleshooting, regulatory compliance issues in the field, and assisting with the setup of monitoring programs at facilities throughout the Northeast. His experience also includes Title V permitting, reporting, and assisting facilities with combating odor issues. JD Mohr has over 19 years experience in the solid waste industry. He is currently manages EnviroCover's ADC sales, marketing, and operations for EPI Environmental Products, Inc. So I will now hand over the screen to Mr. Casullo and JD for their presentation.
Hello. Hi. Thanks for the introduction, Bill. This is JD Mohr. I'm with EPI Environmental. ADC system is EnviroCover. Like Bill said, I've been in the industry for probably about 19 years, 20 years, and started out in the hauling side and moved over into the landfill side. Our product, it's been around for a while, but we're currently have a flagship product that we just started out with. It's called the ECD 800, which is a self-propelled carrier unit that deploys the film. Really how we came to this point is through the need for quick ADC deployment. And that's really was our challenge. Started out at Puente Hills landfill in California, and that's really where we developed the system. Our smaller system is the 700, and some of you might be familiar with that. It's a deployment mechanism that mounts to the front of your primary mover, so you can attach it to your compactor or to a dozer, and you can deploy our film that way. Then we also have another unit that's smaller. It's geared towards small municipal landfills, maybe 200 ton per day and smaller. And that is approximately, it's a 616 unit, and it's basically the same concept that mounts to the front of your primary mover. As far as our case study that we're involved here with GHD, the site that we were working with, they were having some pretty serious odor issues. They decided to with GHD. Again, our system, the EnviroCover, it's made of a non-reusable polyethylene film that we have a proprietary additive on the film that also has certain characteristics that makes it break down a little faster than conventional film. So it won't interfere with the dynamics of the landfill as far as your leachate movement, your gas movement. And it's also destroyed mechanically by the compactors as next day's waste comes in. So just to clarify that our film is a little different as it stays in place versus a removable tarp type system. The next day's waste comes in right on top of our film, and then it's buried along with the next day's waste. It can be used year round. It's great in the wintertime, or a lot of sites have trouble with retrieving tarps. You get a lot of snow on them, so you don't have to fight with that. Then also in the rainy season, it's very useful. We don't have exact metrics, but we do see that it does minimize leachate infiltration. What happens with the film is the water will accumulate on top of the film and basically pool up on top of the film. Also, it's very easy to deploy the film. It's one of the features that a lot of our customers really appreciate, that as far as it's like a turnkey solution, you can get in the machine, deploy the film, and then you park the machine, and it's basically just a turnkey type of ADC. The EnviroCover, it doesn't require removal prior to the next day's waste placement. You get nice continuous coverage. You don't get a lot of flagging or things that are sticking up out of the waste. The odor and emissions control, it's a very impermeable material, polyethylene. As we all know, we use trash bags to contain our waste at our homes. It's the same principle it's impermeable, so it does a really effective job on minimizing the odor and the emissions. And then also the rainwater infiltration, that was the other item that we covered. It complies with all the US EPA requirements. It controls disease vectors, fires, odors, bullying, litter, and scavenging very effectively. So it does meet, check all the boxes there for compliance. It also limits the escape of landfill gas and fugitive emissions, provides ongoing odor control, prevents the rainwater infiltration as we discussed, and also another added benefit, it restricts the air intrusion. So, you don't get any oxygen in. If if you have a fire or something smoldering, it'll help kind of smolder that out. It's puncture resistant. It also stretches over odd-sized items in the landfill as you cover. So as far as the material installation goes, we discussed the film itself. It comes on a roll. It's 18 foot wide, covers approximately 93,500 square foot of area. You do have to account for about a 10% overlap. So you back 10% out of that 93.5, and that'll give you the square footage coverage. And yeah, as we discussed, there's basically 3 different types of deployment devices. Flagship deployer is the ECD-800. That's a self-propelled rubber track unit. Utilizes a Maruca, which if you're familiar with that in the landfill industry, a lot of times the Marucas are utilized for as dump trucks to get in and out of soft areas. So it has really low ground pressure, and that allows it to operate over the top of the waste effectively. So you load the ballast in the machine, so you can use a sand, an aggregate, or even a flowable type soil that goes in the bed. And then as you drive along the working face over the waste, the film is laid out behind the machine, and the ballast is deposited on top of the film. It creates an anchoring effect. And then also where your overlaps are, it creates more of a seal between the overlaps. And as we discussed, it's a very quick method of application. It's a rate of about 3,200 square foot per minute. It handles slopes very well, 3-to-1 slopes. So a lot of times it's difficult to get a large tarping system in some areas where you may have either very steep slopes or some odd angles. We don't recommend to use it on anything steeper than a 3-to-1. And also that the film is deployed up and down the working face, up and down the slope. The overlaps are about 12 to 18 inches, and that creates the seal we discussed. And also if you do have something that's sticking up out of the landfill, such as a spool or rebar or that kind of thing, you can actually back over the film, and in essence just patch the area that had a puncture. And I'm going to turn it over now to Michael. He's going to discuss the case study in Western New York. And Michael, take it over.
Sure. All right, thanks, JD. Sorry for the technical difficulties. Presenting to you today from the ghost town, previously known as GHD's Niagara Falls office. Whether you're viewing this from your kitchen table or your basement or your own office, I sincerely hope that you're all safe and doing well. So before I get going, just want to say a quick thank you to the organizers for letting us present today. So now you know about the EnviroCover system, how it can be developed, deployed, and some of the benefits that it offers as an alternative daily cover or ADC. So going forward, I'll be speaking to you about the case study that we performed and what we learned from it. So why test EnviroCover? Like, what are we hoping to achieve? So the site was experiencing odor complaints, and it felt that some of the more noticeable ones were located at the working face. So they did an in-depth investigation to try and determine the source. The site was previously using soil as the majority of their ADC material. So one of the findings was that the odors at the working face were strongest in the morning. So after more discussion, the odors were determined to be due to the process of stripping the daily soil cover and exposing the waste from the previous day. So this finding caused the site to look into what sort of ADC materials might exist, that they may not require removal every morning and could assist with controlling the odors at the working face. So next we'll discuss the type of materials that were researched. The client reviewed and tested various soil cover types to see if they had any effect on odors. However, this was not an ideal solution as it didn't really provide an advantage. Operations would still need to perform soil stripping to start each day. Next, they looked into traditional tarps. These tarps had the benefits of being easily installed, typically worked in all weather conditions, and controlled litter and vectors. However, they did not really assist with the site's odor issues. Another approach they researched was spray-on cover applications. After speaking with some of the operators, they explained that they generally found it difficult to get adequate coverage over the entire working face, and that the application didn't consistently work well under all weather conditions, especially during periods that were particularly cold or wet. And the last option was EnviroCover, which we'll discuss more. So based on the information supplied by EPI to the client, EnviroCover sounded like a potential solution for the site. A big selling point was that removal of the application was not required, so the material would be mechanically destroyed on the subsequent placement of waste. Therefore, it would not impede the movement of landfill gas or any leachate. However, the site wanted to make sure that they weren't creating any other issues by introducing impermeable layers within the waste. The material is resistant to tearing and puncturing as it has high tensile strength and elongation, but it needed to function as designed under typical working face conditions, which, as we all know, can vary on a daily basis. So they would also need to perform in all types of weather, and around here, I'm sure you know, the weather can change in a moment's notice. So lastly, it also conserved airspace, and what site doesn't like that? So after considering all of EnviroCover's details, the site wanted to conduct a pilot test to make sure that the product would work as planned. The site submitted an application to the state regulators to conduct initial pilot testing in December 2018. The state was intrigued by the technology and its ability to potentially reduce odors, so it was approved initially for a 30-day trial period. EPI made sure to be on site for the study in order to assist in any way possible. After all, it was a new type of cover system for the client, so they really wanted to make sure that they got a good sense of the product and that it was being implemented properly. The client worked with EPI and was able to rent the equipment from them for the pilot test. This allowed the client to spend a limited upfront cost other than the cost of the actual material being used. And it should be noted that while cost is obviously a factor and was a consideration by the facility, cost consideration is not something that was included as part of this evaluation. So as you can see here, here's some of the pictures from the initial pilot test in the winter of December 2018 and January 2019. The EnviroCover is in place. Oh, sorry about that. Got ahead of me. The EnviroCover is in place and ballasted along the edges by soil. So throughout the initial pilot testing, the study was subject to several different weather conditions, including both wet and snowy weather, extreme cold, and windy weather. As advertised, the material could be deployed under these harsh weather conditions and stayed in place as planned. Due to the effectiveness of helping to reduce the escape of odors, we believe that EnviroCover also aids in reducing fugitive emissions. So pictured here are two close-ups of the EnviroCover after some of the time had elapsed. These photos illustrate how the impermeable barrier blocks the water vapor that causes condensation. The vapor is caught under the material, so that would suggest that EnviroCover would likely help to minimize fugitive emissions. It should be noted that surface emission monitoring of the working face was not performed as part of this case study. Therefore, while there was anecdotal evidence in the reduction of emissions through observations made, no actual testing was performed to confirm this. Okay, so odor intensity is determined using ASTM E544. And odor intensity refers to the overall strength of the perceived odor. So the more intense the odor, the more likely an individual will react negatively to it. So even pleasant odors can be too much at high intensities, and conversely, offensive odors can be very annoying at low intensities. A common example is when someone in your office or at home now, wherever, is wearing an excessive amount of cologne or perfume. Typically, those are pleasant smells, but in those cases, it makes it just way too intense for any person. When performing an odor intensity test, the field observation is expressed in parts per million of N-butanol, hence why the informal designation of this is the N-butanol scale. So the N-butanol scale helps classify odor into levels of intensity ranging from 0 to 8. So for this study, site personnel were trained as well as myself, 2 other members of GHD, personnel from another consulting firm, and even some members of a local community group. And let me tell you, not all the smells that they tested us with were pleasant and on the lower end of the scale. I really secretly think that they enjoyed watching us wince and gasp for air while we were being trained. But after taking the training and performing some assessments, it really was impressive how a group of people with varying degrees of sense of smell could end up determining reasonably similar results. So as part of a larger effort related to odor assessment and mitigation, personnel were on site to perform odor intensity readings in January 2019. The evening prior to the odor intensity testing, only part of the working face was covered using EnviroCover, while the remaining area was covered with soil. This allowed the 2 areas to be compared the next morning. Prior to starting operations that morning, odor intensity readings were taken. For the area where soil cover was placed, personnel determined that readings ranged from 0.5 to 1.0. In the area of the EnviroCover, only a trace odor was perceptible to the personnel present. So as a check, an 8 by 10 foot section of the EnviroCover was cut open in order to perform a reading. Immediately, the odor intensity spiked from trace amounts to 1.0. After 15 minutes, the intensity backed down to a 0.5, and then was similarly background intensity shortly thereafter as the odor dissipated. So due to the results, it was concluded that EnviroCover does have an ability to limit odors and likely any associated fugitive emissions. Based on the initial results, the site wanted to extend the trial period in order to be sure that they considered performance during seasonal variations and long-term operational aspects. So the state regulators also wanted to get a chance to see it in use and be able to evaluate the effect on odor control over a longer period. So they also wanted to see if the use of the material had any impact on the number of odor complaints received. Therefore, the initial pilot test was extended from 30 days to 6 months. And due to the fact that the findings from the pilot test were promising, the site submitted an application for EnviroCover to be added to their approved list of ADCs, and that was approved by the state. The site has been using the material as part of their regular operations, and the results have been positive. So lastly, some takeaways. Unfortunately, we are not aware of any single cover system that will work the best for every application. If you have an operational issue, we recommend researching potential ADC applications that may be able to assist your facility. This will allow you to determine what works best for you. Keep in mind that what works at one site or what one operator may really like and or prefer may not be the best application for your site. I will say though that most vendors are completely willing to help you test their material at your site by either renting the equipment to you or something similar to make sure it will perform up to your expectations. So also sometimes the products do really work as well as advertised and can be part of the solution for those hard to solve operational issues. This is especially the case if odors due to cover stripping are an issue at your site. And if so, EnviroCover may be a good alternative to typical cover materials, considering it's performed positively during our study. So in closing, just wanted to say thank you very much for listening. I appreciate your time and the opportunity to share our study with you today.
Okay, thank you, Michael, and thank you, JD. Right now, I'm not getting any questions typed, so I would encourage all the attendees to please type in any questions you might have. But we are also pretty much right on schedule, so we're going to be moving into our next presentation. I know we missed a few slides for JD's presentation, so again, they're going to be ultimately posted on the Federation website, and Michael's and JD's contact information will be posted as well. So our next presentation is geosynthetic solutions to control landfill gas surface emissions. We have two presenters. We have Mr. Elliot Pugh with Wind Defender out of Pottsville, PA, and Stefan Formant with Afitex Texel. And to give you some bio on them, Stefan has been with Afitex Texel since 2004. His most recent experience is in business development and technical sales for drainage geocomposites. Mr. Formant received his engineering degree in geotechnical engineering and his master's degree in civil engineering and physics, and he is also a SWANA member. Mr. Pugh, after receiving his bachelor's degree in civil engineering from Widener University, he worked as a project manager and estimator for a general contractor focused in landfill construction, and he is now the sales manager for Wind Defender LLC, a geosynthetic supply company with a new and innovative product used to ballast exposed geomembrane cover systems. So with that introduction, I'd like to hand it over to Stefan and Elliot for your presentation.
Thank you. Hello, everyone. So I will start the presentation, the first half of the presentation, and then give the hand to Elliot. The presentation is on geosynthetic solutions to control LFG surface emissions. So basically, we'll talk about temporary caps. They are more and more used because they permit to delay the construction of the final cover. They reduce the leachate generation, and they help to improve the LFG collection and to control the odors. The issues you may have with temporary caps is the ballast of the exposed geomembrane. If the geomembrane is not well ballast, you may have uplift of it, and the traditional way to ballast the geomembrane is to put a lot of sandbags to maintain the geomembrane in place, and Elliot will show you an enhanced way to have a ballast on the geomembrane and to get rid of the sandbags. On my part, I will talk about a second issue you may have with temporary caps. So that is the efficient collection of the LFG. Most of the time, you will have perforated pipes under the geomembrane, placed every 30-40 feet, and you may not be able to catch all the LFG from that with that system. So first, let me introduce a way to collect the LFG under the geomembrane using a multilinear drainage geocomposite. The multilinear drainage geocomposite is a drainage geocomposite with drainage conduits regularly spaced between two geotextiles. In our case, the drainage conduits are perforated polypropylene mini pipes. They are placed in the product every 10, 20, 40, or 80 inches, function of the flow capacity you will need, and the diameter of the mini pipe may be 20 or 25 millimeter. The product is delivered in rolls, 13.1 feet wide, 246 feet long. We can, as we can play with the spacing of the mini pipes, or also the geotextile layers can go from 4 ounces per square yard to 60 ounces per square yard if you need really a product with a really high mechanical properties. And it is used for water drainage, leachate collection, and in our case for gas collection. And the main advantage of the product is that the mini pipes have high compressive resistance. The pipe stiffness at 5% deflection is over 435 psi. So the transmissivity of the product, function of the number of mini pipes into the product, can reach 4 × 10⁻³ and the product, even the product is light and flexible. It will keep its drainage capacity over time, because you won't have it won't suffer creep in compression nor geotextile intrusion. It is used in North America for water drainage on geomembrane and LFG collection below the geomembrane for final covers, used for fugitive gas collection on temporary covers. We'll go into that just after. And it is used also in the waste mass for horizontal LFG collection, intermediate leachate drainage, and at the bottom of the cell for a primary and secondary leachate collection system, and for water suppression system. So the installation of the product is quite simple, almost like a geotextile. Between two rolls, you will have an overlap. Function of the position of the drain tube, of the exposition of the drain tube. You may get welds between the rolls or sewing, but for temporary cover under a geomembrane, an overlap sometimes is sufficient, a simple overlap. And end-to-end connections, you connect the mini pipes together using couplers provided in the rolls. The main point of using that type of product for LFG collection is that you can actually connect each mini pipe of the product to the main header pipe using a quick connect system. The quick connect system is the grommets that are in nitrile, and in fact you drill the hole in the main header pipe. You connect these grommets, and after that you insert the mini pipe into these grommets. You can see on the picture that you need to protect the mini pipes from the surrounding soil, because they are perforated, and so you want to prevent any soil particle going into the mini pipes. So you need to protect by with the geotextile or with the geotextile layers of the product. You want to protect the mini pipes. Okay. Here some typical cross section of the connection of the mini pipe to a main header pipe. You can have a simple connection or a double connection, function of the position of the header pipe into the system. There is the connection is really just a mechanical connection. There is no glue to add. There is no weld to do. It is just mechanical. So as you can see on this picture, one of the issue you might have using this type of connection on the side of the temporary cover is that you may have some air intrusion into the system due to the mini pipe, the perforated mini pipe, just on the side of the temporary covers. So just on the side of the geomembrane. To prevent that, we develop other tools that are solid 1-inch pipe and T-connectors. They are these tools permits to limit the head losses near the main heater pipe. And how they are doing that? It is because the T-connectors reduce the number of penetration needed into the main heater pipe. You can see here on the picture that you have 4 pipes that are going into just one pipe, one mini pipe, and this mini pipe will be connected to the main heater pipe. This last mini pipe is a solid mini pipe. And so for the last 3 to 5 feet, you have solid mini pipes, and so you will limit the air intrusion into the system, even if you are on the side of the temporary cover. The main advantage of that system over a pipe, a perforated pipe, is that it is easy to install. It's just a roll, just rolls to deploy, and there is no pipe welding to do. All the connections are mechanical connections. In terms of performance, compared to a perforated pipe, a 6-inch perforated pipe, you will have a greater zone of influence. Basically because strips are 13.5 feet wide, and you have also the possibility, instead of putting only strips of product, you have the possibility to cover the entire area of the temporary cover. And also because of the shape of the mini pipes, and a lot of mini pipes, instead of one big pipe, you have less vacuum dissipation compared to a 6-inch diameter pipe. You can see that on the graph on your left. The blue line is the vacuum dissipation along the conventional perforated pipe, where the point brown line is the vacuum dissipation for the drain tube, and you can see that the drain tube remain more flat, and you have less vacuum dissipation over the length. And the graph on your right is a comparison of the collection, the flow rate capacity of each system. The blue bars are the conventional perforated pipe, and the green bars are the drain tube. And you can see that both systems reach 200 cubic feet per minute in terms of flow rates. One of the last advantage of the product is that it will keep its collection capacity, its drainage capacity over time and under load. Tests have been carried out with a multilinear drainage composite under 50,000 PSF, product being placed between a geomembrane and sand. And you can see that even after 1,000 hours under that conditions, the product keep its transmissivity constant. So that means that the long-term drainage capacity or collection capacity of the product will remain. Some pictures of the installation of the drain tube, first in strips, then in full area, and details of the connection of the mini pipe to the main heater pipe using the quick connect system. After placing the drain tube, you will install the geomembrane directly on top, and then the ballast system that Elliot will talk about. So I give you, Elliot, the hand to continue the presentation. Thank you.
Okay, can everybody see my screen? Stefan, can you see it?
No, I see you for the
You
moment.
see me? All right. How about now?
Yeah, we don't have it yet, Elliot.
All right, give me a second. There we go.
There we go.
Okay, I'm Elliot Pugh. I'm going to take you through the Wind Defender portion of the presentation. Thanks, Stefan, for leading in very nicely with our last project we did together. As you all know, temporary caps or interim covers, they're not something brand new. The traditional means for doing these interim closures has typically been using some kind of geocomposite with some type of barrier being a membrane, usually a 40 mil membrane, and then your ballast system, which traditionally has been a soil cover before exposed membranes started to find their way onto landfills. And as you know, with the soil cover, there was a lot of maintenance issues with, keeping the grass cut and establishing vegetation in the first place and fixing erosion rills. So really the trend now that I'm seeing towards a lot of these solid waste facilities, as well as coal ash landfills, has been moving towards a more exposed membrane cover approach, which of course eliminates that soil cover. And if you have this area covered for 5, 10, 20 years, when you come back to it, all that's left to be done is to remove the membrane cover, and you can get right back into your waste mass and start placing more waste. So you kind of eliminate a lot of the construction costs of placing soil, maintaining it, and then removing it eventually. Just the photo you see right there is a site we did in North Carolina. And it's just wanted to mention that that was done using a 12 mil Durascrim geomembrane. So for those of you that aren't familiar with it, typically we're using 40 mil type products. I do have some here. I'm sure you can't see them that great, but you can kind of see the reinforcement in the 12 mil geomembrane product. It's very thin material. And then of course our Wind Defender product, which is porous. You can see through it. This was our original color for the product to try and blend in with the surroundings. What we found out over time is that it kind of started to look a little bit more blue-green, and a lot of the landfills we were using it on often have some bare dirt patches. So we've now transferred to a bit of a tan-green combination, which is reversible, can be applied either side facing up. So before I get into it any further, who is Wind Defender? What are we? We're a geosynthetics distribution company. We started the company in 2014, and our focus outside of just Wind Defender is also providing a variety of geosynthetic products, from liner to textiles to drain tube to rope and sandbags to sewing thread. We really are kind of a one-stop shop for a lot of the geosynthetic needs. With the Wind Defender product, we really see it used in 3 different applications. They're going to either be used in your cell rain cover applications, which usually utilize an 8 mil Durascrim geomembrane, as well as our Wind Defender ballast system. We'll see it in the temporary or interim covers, which is what the presentation is focused on today. That we'll see used on anything from 12 mil and up to 60 mil, textured, non-textured, anything. And then as well as stockpile covers. And that again, we do a lot with 8 to 12 mil membranes. So as Stefan said, these temporary covers, of course, we're here to focus on controlling odors, but they really have the same benefits as a final closure system. You know, you're essentially eliminating the leachate production by shedding all the rainwater off and controlling erosion and reducing site maintenance. And as Stefan said, you know, the biggest issue with any of these exposed covers is how are you going to ballast it? How are you going to protect your investment? After, you know, the traditional soil cover was used, rope and sandbag system is probably one of the most widely used methods. As you can see in the photo attached or on the screen here, the rope and sandbag system is still in place there, but you're still seeing damage occurring to the membrane just due to wind whip and suction effect over time, and then the liner will essentially get a hole in it and air gets underneath there, and then you're in trouble. Some of the other traditional ballast methods out there, other than sandbags, you have your tires, you know, soil windrows you could place out on your lining system. There's also ground anchors. You know, a lot of these systems, you know, the tires are not available to everybody. Soil is not always readily available on site, but also it's going to be a pain to get out and place that on top of your liner system. And then the ground anchor system, you know, I've heard a lot of positives, but I've also heard, you know, a lot of people, you know, get a little nervous when you're punching holes through the liner that's supposed to be protecting any infiltration from occurring in the first place. So as I said, the most popular used method is probably the rope and sandbag system. As you can see on the left, you can see where we're having some snow loading occur on this system. And essentially what happens is the snow load builds up on those sandbags and causes the rope lines to fail. Makes sense. Another kind of a neat fact for safety wise versus our Wind Defender product, a roll of Wind Defender is roughly 325 pounds and can cover an area of about 6,500 square feet. If you were going to do the same scenario with a 5x10 rope and sandbag grid, you know, those installers have to carry out roughly 4,000 pounds of sandbags just to place in that same area that a roll of Wind Defender would cover. But I guess really the biggest thing is first understanding what we have to control. And there's two main forces that you have to control or battle when it comes to ballasting a membrane, and that's crosswinds or wind uplift or negative pressure. So the traditional methods have always been used to, you know, use the method of, hey, put enough weight on it, put enough point loading on it, and it'll hold the liner down and stop it from blowing away. You can see on the photo on the left, this is actually a site in Tennessee, and it is the only site that I've ever seen that many sandbags used to ballast the membrane. Those sandbags were spaced about 2 feet apart, and I feel very badly for the installers that had to put those in. We actually went out to that site and installed a 7-acre section right next to that area with Wind Defender and a 40 mil micro spike liner by Agru. And it was kind of a neat site. The area to the left was 7 acres. Then the area to the right of that was 7 acres of Wind Defender and 40 mil. And the goal of the site was to prolong having to do the final closure system until they procured enough funds. So they were able to kind of break up their installation into multiple years. So year 1, they did 7 acres with sandbags. Year 2, they did 7 acres with Wind Defender. Then year 3, they came back. We're actually able to remove the Wind Defender and reuse it, and then remove all the sandbags and you know, actually cover it with the final closure system. So here's a short video. It kind of demonstrates how the Wind Defender works. I know a lot of people always ask, you know, how does it work? It's, you know, it's not heavy. So you see, this is basically depicting what's happening on every landfill out there. The flow of air is coming across the top of the slope, and it creates that suction effect or that negative pressure, which is usually greatest towards the top of your slope. That'll draw the membrane up and off the subgrade. So when wind defender is applied, it's essentially diffusing that uplift force. You can see with our high-tech picture and video here, as the air is being drawn up from the membrane, it's actually being replaced with a downward force of air to kind of cancel out that uplift force. So the material itself is knitted UV stabilized HDPE geotextile. So the filament itself is high density polyethylene. They're knitted together. Comes shipped to your job site just like a roll of liner, except the material is C-folded. So it's a 20-foot wide by 328-foot long roll, but the 20 feet wide is folded in half. So you'll get a 10-foot long roll. You unroll it and then unfold it to make 20 feet. You can see the sewing machine in the guy's hand there. That's how we seam our panels together. And the installation process is pretty simple. You'll deploy about 2 or 3 panels, seam them together, and then line your crew up on the leading edge of material and actually tension the system into place. Sewing threads, I think, is often overlooked when it comes to seaming a lot of the geosynthetics in our industry. But typically a polyester thread's used. We recommend a minimum of a 277 polyester bonded thread. And I like to say use that type of thread for a less than 10-year service life. We have since, in the past couple of years, have introduced a GeoFix thread, which is the only thread that I've been able to find that comes with a limited lifetime warranty. And we'll recommend that on a 10-year plus expected service life project. Just a couple of typical details. I always like to show the one on the top right because oftentimes I get through this presentation and somebody will ask, well, there's holes in wind defender. How does that stop rainwater from infiltrating into my slope? It goes on top of the geomembrane, and just below the geomembrane, we'll see Stefan's drain tube product to collect some surface gas. As I said, typical seams for the material is just a simple prayer seam. We like to see about 3 inches of material above that thread line for a proper seam. Obviously, terminating the product around the perimeter is always, we'd always like to see it go in an anchor trench. We'll put it right on top of the geomembrane in, your typical 2x2 anchor trench. Obviously, this isn't possible everywhere. Oftentimes at the toe of slope, you might run your liner out into a swale or perimeter ditch. And with the wind defender being in tension, we try to keep it out of those ditches to keep it, easy for you to have to clean out if you do in the future, as well as prevent any kind of trampolining or bridging in the wind defender system. So what we do a lot is we'll do a kind of a sandbag burrito method. So in that top detail here, you can see where we run the wind defender down and actually loop it around the sandbag and sew it to itself. And that's proven very effective to also keep the tension on the system down the slope. When it comes to testing, pretty standard. We do manufacturer quality control as well as third-party quality assurance testing. We've done long-term accelerated UV testing for 15 months, and based on those results, our system has a half-life of 55 years and an expected service life of 90 years. Obviously, that's in the lab. Might be slightly different out in the field, but really great UV properties to our system, as well as some wind tunnel testing that we've done up to 110 miles an hour without any damage. In addition to that, many of the engineers were interested in, kind of some of the properties involving runoff. Everybody knows once it's raining on top of the membrane, you're getting 100% of the rain, basically. With the wind defender, we found that we have a Manning's coefficient very close to that of grass. So we do see some reduced flow rates with the wind defender system, just something to keep in mind when you're designing. So here's a short video. It's one thing for me to tell you about the product, but it's another thing to actually see it. This is over top of a 40 mil liner. You can see on that side, wind defender is staying pretty still. And as you pan across the other side, you get a good glimpse of what a 40 mil unballasted membrane does in high winds. So kind of tough to see, but that bubble you're looking at is probably about 4 feet off of the ground, in a pretty windy day. And as I mentioned earlier, this is a photo and video from that installation where we were able to reuse the wind defender. So you can see in the picture to the left, what they're able to do is take 3 panels wide at a time when they remove it and basically fold them in on each other. And then the installer here came up with a nifty idea to attach an auger attachment to the front of their skid steer with a piece of PVC pipe used as a core. And we're actually able to re-roll the material, and you can see the re-rolled rolls on the right. So just a couple little photos from some sites, you know, just kind of see your transition over the past 6 years in business. One of our first installations was a 50,000 square foot temporary cap where they had your traditional rope and sandbag system, had some wind damage, came back and repaired the rain cover as well as installed the wind defender. Then in 2016, we saw one of our first, I would almost call it like a complete capping job. And this was about a 30-acre installation over top of 40 mil. One thing to note about this installation is around the entire perimeter where the wind defender is terminated, there is a perimeter swale that the liner runs through, but the wind defender is actually terminated just up the slope from that using that sandbag burrito method. So around this entire area, there is no anchor trench. It's all a sandbag burrito. The only other thing that's holding it down or putting any other weight on it would be this access road constructed across the top of the landfill. And that project still is in service. And then you get to some of our more recent projects. This is our largest installation to date. This is a 90-acre installation on a coal ash basin that they're kind of, you're looking at it halfway through the installation roughly. You can see to the left, this is where they're fighting to dewater this ash pond. And as they're dewatering it, you know, they're capping with 40 mil and the wind defender on top. One thing to note in this picture, you can see kind of some color difference between these two areas. And that's due to having the wind defender installed this direction and then flipped upside down. So you can see there's a more tan appearance on this side versus a more green appearance on this. So have to pay attention when you install it to stay consistent with your color. To date, we have over 84 million square feet installed across the US. We have also installations in Canada and Hawaii. And, you know, out of all those installations, we've had 0 catastrophic failures, haven't had any blow-offs. As far as maintenance is concerned, you might have some holes, you know, from animals that can be very easily patched up and sewn a patch around. And the other thing you'll see is seam failure, either due to, you know, not enough an overlap on the seam, and while the material is kind of in tension, that seam tends to split apart. Again, not a very difficult fix. It's not detrimental to your cover system. We can come right back in there and essentially sew another piece of wind defender into the split seam. And those sites are, you know, solid waste, power generation, and stockpile covers that you're seeing. So in conclusion, I'd say we've heard a lot about ways to control odor, you know, from shorter term solutions to longer term solutions. And I think, you know, with some of these new and innovative products, it's nice to see that, you know, the industry is still advancing and there's new things out there to consider and evaluate. I'm not going to tell you that the wind defender is the end all be all. If you have an installation that you know is only going to last for 6 months, I wouldn't recommend using wind defender. It is slightly more of a premium product versus your rope and sandbag system. And I'm sure Bill might ask me this question, so I'll answer it right now. But you're looking at roughly I'd say about a 17 cents per square foot material cost, and then 12 cents a square foot as an installation cost for placing the wind defender. So I guess I'll open it up for any questions anybody has.
Yeah, thank you, Elliot. Thank you, Stefan. That's the word innovative. Innovative is right on. That's a very interesting presentation. Any last minute questions can be typed in the Q&A. Presently, we do not have any, and we are right on schedule. It's a few minutes after 3, so I'd like to thank all the presenters. Thank you all for attending. Again, we'll have all this information up on the Federation website, and obviously contact information for the presenter. So thank you again, gentlemen.
Thank you.
Thank you.
Kelly, we have any last minute announcements before we adjourn?
Just that the last session is next Thursday, the 29th, and anybody who's already registered is already registered for those days, so they are welcome to join us. So thank you, everybody. Great session. Thanks to our presenters and to our attendees, and have a nice day. Have a nice weekend.
Thanks, Kelly.
Thanks, everyone.